Hello everyone, welcome back to the day 4 of our boot camp, the second last day. People are still coming. Please, if you have friends who are also going with us this boot camp, kindly inform them to join. And first of all, happy Raksha Bandhan to all of you guys. Good evening, good evening. So today is day 4 and we are going to do some transfer learning and hyper tuning also, like how we are going to optimize our model more and more. Yeah, happy Rakshabandhan to everyone. Hope you guys were enjoying the evening, but as we have been scheduled with this boot camp, we must go on for one half hour or 1.5 hour. Happy Rakshabandhan. So I think we should start now, or people are still joining. Should we start? Yes. First of all, everyone who are with us from day one, please, like here is an option: run all. Put it in run all so that all your above logs will be compiled. There's some network, actually some network glitch. Am I audible and clearly visible? My screen is clearly visible to you guys. Just message. Yes, yes, sir. Actually, there was some network glitch. That why it started buffering. Just a second, guys. I actually facing some technical issue. Okay, now let's start with our day 5. So we are going to start with the first question. What is pre-trained model? Like many of you guys were having questions. Like today we are going to work on this only. So if you have question like what is pre-trained model, a pre-trained model is a neural network. Like it is a form, like as I earlier told, neural network is day 4. Yes, it is a day 4. Okay. 1080p. Yeah, I can understand because I was facing some issue. I will try to increase the size so you guys can easily get. I think now screen is visible. So like we were talking about what are pre-trained models. Pre-trained models is a neural network that has already been trained on a larger data sets which we are using right now, or we are going to use. Just a second, I think it got okay, it's running. So which we like it was already trained before we were using it, or it has been trained on a very large data set with millions of images, like ImageNet or MobileNet of data sets which have been already trained with a huge amount of images. Moving on, it has like already learned to detect useful features like edges, shapes, colors, and textures also, which we are trying to like train our new model, or we are trying to like execute how it is going to be done. So these models are already trained and worked upon, or already been like level up of what we are thinking also. So instead of like we are going to compare it from like if we have to fine tune the our models. So instead of like starting from scratch again and again, going, we are going to just compare it with the pre-trained models and reuse the knowledge for our own task. So some of the example of pre-trained models are, let me like MobileNet, MobileNet V2, then we have ResNet, then we have even some of the like VGGs also, then we have like ImageNet also. So these are kind of pre-trained models. Then moving forward, what is transfer learning? Many will be having question, what is actually transfer learning? Transfer learning is actually means that taking pre-trained models and using it for new or kind of similar models which we are going to build. How you can know it's a pre-trained model? Pre-trained models are very like you can't like, if you are going to work upon some new model, you just can't say directly. Instead you have to like work upon how it is. You have to tell like when you search upon Google, you will get some like all these models are pre-trained, or models which are already performing goods are called as pre-trained models. by just looking you can't tell on anyone else can tell on larger scale. We use them for our newer models in comparison. Sorry guys, there was some network issue. I think now screen is visible. Uh, I think now screen is visible. Yes. Oh, visible now. Still sticking network. Yeah, there was some network issue. So I think we can like proceed back. Let it and put it on run. Guys, you all also just run your whole code till the time we are explaining and moving forward. So once you move forward, you doesn't get stuck. So I think we were on transfer learning. So what I think we were transfer learning. So we should start again on transfer. So I was talking about transfer learning. Transfer learning means actually using pre-trained models and using it, and we can and using it we can train our new models, which has also similar tasks to do. We like don't train our model from zero. We transfer the learned patterns to our new problems. Like if we have to like tell our model how to recognize new patterns of new images, so if we do it from scratch, it will take lot of time and lot of data. So we just like transfer as our professors or teachers have studied from their seniors. Is it got stuck again? Okay, it's working fine. So as we studied from our teachers or professors, they have learned from their teachers or professor, and they transfer their experience and studies to us, like how they have researched, how they have worked. So we don't have to work from scratch. They train us. Same way we transfer the learning from the pre-trained models to us, to our new model. This makes actually training faster and often accurate, because model start with strong prior knowledge only. So we don't have to start from zero. So moving forward with the question, how to fine tune and optimize. Like many people face problem in this only, like how to fine tune or like optimize the whole model with our system. So fine tuning is a process of unfreezing some, like unfreezing some or all the layers. If we want, we can unfreeze some layers only. If like suppose our CNN compose of 4 or 6 layers, we can like unfreeze only 2 or 3, and even all, like we have to unfreeze all the layers of the pre-trained models, and then retaining them with a very small learning of rate. Like we extract small learning from the pre-trained models to our model, so that we can fine tune and optimize it better. Please revise. Yeah, we will revise all the back once we will be done with today's, because I think today we have to cover a lot, because tomorrow is the last day. So we can't cover all the things tomorrow. So like tomorrow we have to deploy also. So I will try to cover maximum today. So if not possible, on the last day, we will cover all 5 days in a quick recap, so everyone gets to know what we have done done in the last 5 days, last 4 days actually. Explain fine tuning again. Okay, so listen carefully. Like fine tuning is the process of unfreezing some or all the layers of the pre-trained models. Like we can either unfreeze some layers or even all the layers of the pre-trained models, and while retaining them with a very small learning rate. Like we have to retain them we have to retain all of them with a very small learning rate. Like we can't extract whole altogether, we can't learn all whole together. We have to like learn day by day, as we are learning from day 1 to day 2, day 3, and now we have reached day 4. We didn't directly fine tune on the day 1, so we have to like increase our rate day by day. It includes some of these steps like load a pre-trained model, then we have to freeze first or second layer, then add your we have to even add a custom layer of your problems. Like if your like model is working on a same pattern, but still you have to like add some extra problem which you are facing or extra problem you are resolving, so you can add a custom layer. Then we can train only the custom layer feature. Like as we have added the custom layer, as we have added the custom layer, so we can extract the features at that stage. Then moving forward, as I told earlier, we have to unfreeze some of the layers of the base model. The base model is the pre-tuned pre-trained model. If you got, this is a base model here on which we are building our whole model. Then we have to train again with low learning rate. Like we can't learn all the things. Like here some people were telling that topic is going overhead. I can understand it is a tough topic, so you have to study in brief, you have to like put your extra efforts also. So here also like train we have to train the whole model again. Like you will see I am going to train again the model with low learning rate. We can't just make all the learning at once only. To make kind like we do small learning rate to make some adjustments if we want in that feature. And we like small learning rate is also used because we don't want to erase what model has already known, uh, just to fine tune it for our data. Like if model is knowing something else also, and if we try to teach him very fast, then he might got forgot what he has already learned. Same way like you guys also study. If in one day only, like continuous I take for 5 hours of the whole boot camp continuously for 5 hours, you guys might got get frustrated because continuously and in the fast way you can't learn all the things at once. I think everyone got to know what is fine tune and how to optimize. So let's move forward with how to deploy model. Like deploying model is the main task for which we are working, for which we are sitting for hours and 1.5 hour for last 3 to 4 days. So after training, we have to like deploy the model so other can also use it. Like all the coders, if they just want to use by themselves, they can easily use. But to make it usable for others also, it is kind of tough task. So we have to like work upon how it's going to be deploy. We have to deploy using, like if we want to use web apps, like we can use Flask, Django, or even Streamlit. For beginners I will suggest Streamlit because it is most user friendly and even free also. So even you can like first of all host and check how it is looking, and then later you can deploy it also on the Streamlit anywhere if you want. And if you want like mobile app, then you have to convert the TensorFlow, convert to TensorFlow Lite or even to Core ML. If you want to, like, mobile can't host all this big models at once. Then if you want just to cloud deployment, you have to like deploy in clouds, like you have listen about cloud services like AWS, Google Cloud or Azure. You can use them. And even API hosting is also available. You can host your model as an API, so apps can send images and get prediction. But for that you need a server, so that is not possible right now. So we will try to host or deploy it on Streamlit, so others can also use. I think this much we are done, guys. Do you guys understand? So we move with like loading the models for today. Okay, I have run all the programs, so it is also running. Till then we will just write the code, and once it is done we will move forward. Have you guys run your code? Mine is all your is almost done. Nice. I suggest all of you to just run your code once, so there's no error. Can we use diff Uh, I'm not understanding your question. Please explain in brief so I can answer your question. Done. So now to fine tune, like in this, we are going to use a pre-trained model which has worked upon the images of cat and dog. Like it will classify by looking at an image whether it's a cat or dog. Because you guys are almost different browser. Yes, you can use different browser, but you can. I suggest you all to use Google Colab only. Google Colab works on every browser, I think. So I think where we, yeah, like we are now going to use a pre-trained model of a cat and dog, which will be used to train our initially train all the models on our, that it will help us to classify between a dog or a cat by just giving it an image. What use is optimize it is for better learning. Like we have use of optimize, you are asking. Like if we have already told him like how to write, suppose if I have told a student or child to write a sentence, if I have just told him to write hello good morning, so he will be restricted to that only. Optimizing means I have to teach them or more ways to write the sentence, or even like how we can, instead of writing hello, we can also say hi. Or like for a single word also there's many meanings. So this is the like meaning of optimizing. Like we have to train him more apart of just basics. We are going to deploy the model tomorrow, so you will understand that whole thing tomorrow only. We are going to just save all kind of models which we are going to train. We are going to save and use how it is going to save in our system. How can we say optimize improve the performance of any application? Like I suppose all of you guys are from BTech. When you guys just passed your 12th, how much do you know about coding? Very little. Like I think only basics. You don't know about DSA or automata or operating systems or many things. But as you guys have passed your first year, your second year, your third year, so you guys know about different things you guys got optimized regarding the technology, regarding the artificial intelligence or machine learning. So this is this only all improved your efficiency. That's why you are attending this session, because you got optimized for this training. So you have some basics knowledge, that why you are doing whole of this coding here. So I think we should move forward with loading the data set. It's going on, it's okay. So again we are going to wait a second. I am going to I have given the link to you guys of the data set which we are going to use for training our image, like training our pre-trained. We are going to use this pre-trained model to train our model further. So to just directly instead of downloading and then again uploading on this Google Colab, we will be just directly importing it into our system. Like we are going to Kaggle data sets, as we have already run the API of the Kaggle, so it's going to directly load. We don't have to write again, like we have to download. So this is the data set. You guys can also look from here. It is an image classifier. You guys can copy the like path from here and then also use. So we are directly going to import it once this training is complete. We will run this code. Till then we can just write another code also, which will is going to like run after this. So if you are like thinking what this code is about, this code is just directly telling Kaggle to give me the data of cat and dogs data set from the user. This is the username which they have uploaded. You can see here if it is available. I think it will be available written here in the top. See here it is written Tony Python. So let's I think move forward with the code. We will run this once it got. If you guys have done running all the whole hour, you guys can move forward. By running it will run, and then after that you can like import. It will be downloaded in the zip file. So we have to file dot zip file. We are going to store it in content. So we have to define the location and then cat dash and dash dog dash zip. And once it's got location, we have to like as zip underscore ref. Then we will have to like zip extract all the thing. After like once you download all the file, you usually extract also. So we will extract all in the same folder where we have stored content. Then like we will write the location. We will just change the name. So because we have already, we can also write like just and dogs versus cat we can also write. So I think it has run or not. Let me check. It is still running. It's almost about to be done. We have to wait for just 1 minute. It is almost done. Last code. Yeah, just a second. I am showing. You can see last code. It has done. So now this all score and this heat map we have already done yesterday. So now we will proceed with this code. It has like given you all the link. This link I have already given. You guys can also like click on that and it will directly redirect on that page only. It has downloaded, and once you download that you can unzip it. Like it is done, you can go and check also. See, here you will check the, and it is a zip file which we have earlier got here, and then the file which we have renamed after extracting all the data. Like we have test data also and training data also present in this. So now we should move forward. Now we will prepare the images from the cats and the dog data set which we have extracted. uh, First we have to like prepare like in the first day only I have told you. We have to pre-process some and read them in a right format for training and validation. So we will move forward with that only which we have done initially. You guys must be knowing. So from TensorFlow dot keras dot preprocessing dot image. We have to like import work on image. Import, I think image data generator. Everyone who were present yesterday must have recognized what we are going to do. Then we are just data gen is equals to image data generator. We are going to rescale it, like if we want like 1 by oh, oh sorry 1 point divided by 255, then we can just validation split, like again we are going to 0.2. Once we are done this, then we will like, yes, attendance is recorded. Attendance will be given in last. Today we are not going to have any quiz. We will be having quiz tomorrow. You got an error message. Please check if you have correctly typed or not. If is there any typing change or anything, they might be saying, or if you have run all the above code, which it given or not, you have to check. Then we will train the generators. See, Python is such a easy language. You can just read the code and understand what is going on from directory. Then we have to like take the, we have where stored content. Then I think we have saved with dogs versus cats. I think with the name we have stored. So it's going to like work on that. Then what we are going to have some targeted size in which it going to represent this whole pre-processing we have done in the day one also, all those who have remember. So same way, if once we have imported any data, we will do some pre-processing again, so it can be easily done. Then we also have batch size also. We are going to define the batch size of like 32. Then batch size. Then like we have a class mode also. Mode is equals to like we will have binary. Let me shift to the next line, it's getting longer. Binary, and also we binary, and we will subset the, like we are using as a subset, so we will name it as a training. I hope you guys got this much. So once you are done with this, we will move to like next line. We will validate the underscore generators. In this directory, we will again give the address of content. Just let me, same address we are using. and we are going to like do all this again. So I will just copy the whole, like we have to repeat the steps again. So you can just like do all this. We have uploaded the cats and the dog file for like it is a pre-trained model for the cats and dog, so that's why we have uploaded this. I think this much you guys have done. So have you guys done this one? There is some error. I think I have done some typing error. Let me just check. Okay, it is just, yeah, no, it's got run. There was some typing error. Yeah, invalidated. So, are you guys done this till here? Attendance will be given after 10 to 15 minutes. Yes, no attendance has been conducted yet. It will be given after this. So, I think you guys are done till here. So, just to give you overview of this, what we have done in this, we are like telling Python to go inside the folder of cats and dogs, resize them to size of 20, 224 into 224, and then normalize them so pixels are between 0 to 1 only. And further we will then split them into 80% for training and 20% for like testing during the training. This we have done. So I think we should move forward with, yes sir, done. I think most of the people have done. So we should move forward. Let I have to smaller the screen because the next code is quite bigger. And like, mm, once you guys are done till here, and then we have to import some of the pretend like applications which are built within, like mobile net v2, which I have already tell it is a pre-trained model for images. Then we have import sequential, which we have I think used in the day 2, where we have just started building our CNN model layer by layer. Done. And then we have like one new thing we have imported here, you guys must have be looking. This converts the feature maps into a single value per feature channel. Like it reduces the size while keeping the information, like it will keep like sometimes you have to reduce the size of the file, but you don't want the information to be loose, so it just compresses the whole uh, data into like from 2D to 1D, but keeps the information as it is. And then, as you guys know, dense, it fully connects the layer for making decision making. So once you are done with till here, then we are going to work upon base model is equals to mobile net v2. In this we are going to give weights is equals to image net. I have already, I think, told you guys about image net. Include top is equals to, here we have to declare it as false, and then input shape also 2 to 4, like we have initially given the size. Are you guys done till here? So in this we are actually, it loads the mobile v2 from weights from the image net, and then includes top is equals to false, removes the original classification layer, so we can add our own, like it will remove the original layer which was the model having, so we can uh, add our layers, so we can modify into that. And then image shape is equals to 224 224 comma 3. Our images are like 224 by 224 pixels with three color channels like RGB, what we got. So moving forward with this base model is equals, no, we have training, mm, trainable, we have to, just check that it is whether trainable or not. Here we are declaring it as false. It actually, this code freezes the base layer, which I have also, I think, told. Then moving forward, like model is equals to sequential. Then we have to give base model. Here it is. Then comma. We have to give global average pooling feature here. We have to extract here. Then we have what we are going to do, like dense. In that also we are going to tell which layer activation we have to do, how many we have to set up. And here again, which we have earlier used, relu. Till here I think all of you guys have done. So moving forward, we have in dense is equals to, no, here don't have to put is equals, I think, 1 comma activation. Like earlier we use softmax, but here we are going to use sigmoid. Till here I think you guys are done. So moving forward, we have to like compile, and then we have to start the trading also. So model dot compile, putting optimizer. What optimizer we have used? We have like Adam, then we have loss setup also in this with a binary underscore crossand. trophy. Then we have metrics. In this we are going to set accuracy. Then once we model compile, what we do is model dot fit. This is also question in yesterday quiz. I hope everyone got it. Like most of them were right, except few got like data generator we are going to use. Then I for short time, like we have some short time, we are going to just set off if watch at 5. You can go for 10 also if you have time, but we are moving little fast here because uh, we have some sort of validation data is equals to val generator we have to use here. I think everyone is done till here. So it will start training. There's some trainer metrics. Okay, I have written somewhere metrics wrong here. So it has started the training. It will take some time. Till then, I think we should move forward. Because further also we have to train more. uh, for this code I am just going to explain what we have done is like we have borrowed a brain from mobilenet v2 that already knows how to look at pictures and froze it so it doesn't forgot also, like which initially it was knowing. So while like training our data it doesn't forget that, so we froze it, then adds our own decision making layer and train only the new part to decide whether it is a cat or a dog. This much we have done in this part. Further we will move attendance will be given after some time. I know it's getting late, but it will be given after some time. Otherwise you guys just get stuck in the. So now we have very small code further, so just be quick. Base model only till the time it's running. First write this code, I after that I will give the attendance link. True, we have to here like trainable we are going to true, then we are going to move model dot compile. Here we are going to do more further advancement in that only. Model compile optimizer is equals to we have taken keras as tf dot keras dot optimizer dot adam. In this we have to put a specific value, then moving forward like loss is equals to again binary. We have binary cross trophy. Cross and trophy we are given, then we will give again metrics, what kind of metrics we are going to use. So here we are going to again use accuracy as the metrics. This much we will like compile again because we have changed which layer are trainables, like Adam 1e to 5. It is a very like small learning rate. We it is 1e to 1e dash 5 means it is 0.00001. So we have like 5 digits. Then we will move forward. I think most of you know what we are going to do after this. Like after all time we compile, we like train generator. Then we are going to set if forces. Like we are short of time. Then here we will give three only. Then again we are going to give. I am again saying if force is just like number of times the data is going to be seen by the model. So you can increase or decrease depending upon the time you have. Validation is equals to val underscore generator. This much is to be done in this. Like earlier we used mobile net v2 as fixed camera. It was just looked for a general pattern and pass them on. Now we have unlocked it focus settings so it can adjust and specialize to recognize our cats and images better, like from different angle or from different view. Like we keep the learning rate tiny, so we like erase it original knowledge, so we don't actually erase it because it might get erased earlier. It's training only, it's taking time. So I think we should write the code first, then till the time it's training. So if the session is end also, you guys just have to run all the code after that, so it can be done easily. So once we have done with this, then we have to like save the model which will be will get generated. So just write the code so you can run after that also. This will save the entire trained model into the file called mobilenet cats dogs.h5. So once you are done till here, what you guys explain. Now like we have to further load. So we are going to like to load. This is just comment. You don't understand it as a code. I just to load this. We have saved it, but to load it into our system again. So to load this, we have TensorFlow as TF. What you guys is search. It's day 4. The title is only. Why you guys you asking, sir? Screen code is not clear. S- Just wait a second. Whether it's clear or not, I have to check. Yeah, it is clear. You just have to put it on 180p. I am also using a device to read all your comments, and it is clearly visible in my screen if I'm using it in 1080p. Attendance link, just a second, I'm giving. Uh, Wait for a second, for a minute, I am giving. Today's day 4. Now don't spam unnecessary, otherwise the attendance will link will go up and people will have problem in finding it. I hope. Now moving to next line, loaded model is equals to tf dot keras dot models dot load model. Then we have to like give which model we have to load. uh, Name we have given here. Oh shit. It's still training. It's taking actually time because mobile net is kind of heavy model, so it will be taking time. So I think you guys have received attendance, and after this we have just a single code block left for today. So you guys also note that, and we will finish the session, and you guys can run it and tell like tomorrow tell what you have guys have any problem, because it's already 8:10. Today there will be no quiz. Once like you have done with this, we will move forward with skill, because today we have lot of coding part left, because yesterday we were busy in quiz and everything. Import roc curves and also auc. It will like, if you guys have like you must have the question like what is roc. It calculates the point for the roc curve, like it calculates the points. And auc also, auc is the area under the cover, like what kind of area or what kind of whole pattern it's covering. It is that only. So it tells that what calculated area it is under covering, the auc score. So moving forward, auc moving forward we have like mm, prediction underscore. Now we will go with probability is equals to. loaded underscore model dot predicted predictel dot model dot predict, then well underscore generator. Have you guys done? Done. At last, I will brief the today's code. Just complete this part, so I can just brief you all what all we have done till here. So once you are done with till here, then we have FPR, comma, like TPR, comma, underscore also is equals to ROC curves generator dot classes. Then we have like Y prediction. Then we will move with ROC, like we will take ROC, and AUC is equals to AUC FPR. I'm going to explain all of this. What is FPR and TPR? Just a second. Then we will plot pld dot plot in bracket 0 comma 1, and then we will comma, then we can also have again 0 comma 1, then we will have k minus, then we will like plot x label, false positive rate, and after this we will plot y label for the true positive rate. Till here, then we will like plot legend and plot dot show to show you guys. Till here, I think we are going to do so. Here we are evaluating our model using ROC curve and AUC score to see how well it has distinguished between the cats and the dogs. Then coming to this, like in the first line we have been loading like y prediction probability, this we have written. So it is uses a loaded model to predict the probability of each images in the validation set. Since it's a binary classification, the value near 1 more likely a dog, and a value near 0 is more likely will be of a cat. Like if it is greater than zero point 0.5, if the probability is greater than zero point 0.5, then it will give the prediction as dog, or when the probability is less than zero point 0.5, then it will give as a cat, because if once the value is near 0, it will be going to give you like output or prediction as cat, and if it is greater than 1, it is going to give like a dog. So for moving with this, many guys, you were having a question like what is FPR, what is TPR. So FPR is false positive rate, like cats wrongly predicted as dog, or and true positive rate is the dog correctly predicted as dog only. So it will give all this. This actually gives us a point to plot ROC curves. Then you guys like seeing this ROC underscore AUC is equals to AUC FPR comma TPR. This calculates the area under the ROC curves. Like for 1 it is a perfect model, and for zero point 0.5 it is like randomly guessing what it is or not. Then we are going to plot the ROC curve with AUC score in the label here, and same way, like here you guys must be knowing why it is 0.1 0.1 k dash dash. It actually draws a diagonal dashed line. This is a called as random guessing baseline, because if it is above that it is called as perfect model, if it is below or on that it is just called as randomly guessing. So in whole of this code we can say like the ROC curve is like testing your model at every possible decision point to see how well it separated from cats, like how well it has separated cats from the dogs or dogs from the cats. The AUC score tells how good the separation is. The higher the better, because higher the rate will be, the better it will tell us that it has separated from us. So anyone anyone has completed this training, or anyone system has completed this training? I don't think so, because it will take time. It is a larger model. So it's almost time 8:18. So I'm going to just give the whole overview what we have done today. So from starting, we started by downloading data set like cats and dogs from the Kaggle. Then we have loaded and pre-processed the data by normalizing the pixel values in 0 and 1, and like reshaping the images. Then we have built basic CNN model for convolution like pooling, and then flattening like global average pooling DD, and also converting into a dense after converting all the sequentials connection. Then we trained the model and plotted. We will be plotting here the accuracy graph also. Here we will evaluate the model performance on the test data and check the predictions, like what predictions whether it is meeting. Like also we have improved the data by adding the pre-trained data here, like till yesterday till here we were training a custom data, but moving forward we have imported some of the pre-trained data on, and based on that we are going to train it more further. So this is all what we have done. Once you guys are done with this, just run this and further this and this. It will get executed one by one. Code still running. Yes, I can understand it will take time. Uh, Even once you are the guys done with this, you can try with 10 if watches also, so you can do all the thing. You can like train more, but it will take up to one or even more than half an hour. If you guys want, you can also change like runtime type. If you go here, and you can also get a GPU also for the hardware acceleration. Like currently my whole server is running on CPU only. If you guys want, you can change the runtime to GPU. It will accelerate, but I think it has some limitations of time, or sometimes it even asks for like subscription also to buy the, like, you have to buy the resources. Here it will show you are not subscribed, but when you use at sometimes, because when if you exceed the limit, it shows to it asks you to subscribe. So I think we should end this session here. Once again, some people are asking for the attendance link. I will paste it. If anyone has missed attendance of today, yesterday that quiz was just between all the live people. It got ended yesterday only. It has nothing to do furthermore. So I think we should end this session. You guys just wait and like complete all these training, and once the code is executed till here, so I will request all of you guys, as it will take time. So before, like, tomorrow is the last day, and it will also start at the same time, 7 p.m. You guys like restart your system at approx 5:30 or 6 to run all these code. So by the time the live started, your all the code before that has executed, so we can proceed easily. So I'm ending this session here. See you guys tomorrow on the last day, and hopefully we will deploy this whole project. And you guys have to submit, I think, 30 seconds video of like deployment or prediction, and then the whole post also. I will just confirm and tell you guys tomorrow what all you have to do for the submissions. Okay, till then, bye. See you again, and happy Raksha Bandhan again to all of you guys.